Hello and welcome to section 10.6. In case you guys haven't seen the answers for 10.5, here they are. Today we're going to be working with segments in circles. So 10.5 was about angles in circles, and today we're going to work with segments. So we're going to find different tangent segments and different secant segments. So when two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of the chord. You don't really need to know that. What you do need to know though is this theorem here. So here's our two chords. And I'm going to simplify this up a little bit. We're going to call this A, we're going to call this part B, this part C, and this part D. Basically, you have A times B equals C times D. And this is what you need to know right here. This theorem with this picture, all of that is just, all the words are just explaining that in a fancy way. So, we're going to apply that here in just a second. I got the two other ones. This one's with secant segments, and this one's a little bit different here. Let's see, because I'm going to talk about this one here. So you can see that there's a couple of them here. So I'm going to go over each one, and then I'll do the sample problems. Okay. With this one here, you take A times B, and B is the entire length of that segment there, and then C times D. So it's A times B equals C times D. And the problem is that sometimes students will do this times this equals this times this, okay? And that's wrong. So don't do that. Okay, so let's see. Again, all the vocab in this section really doesn't matter too much. You just need to know for this section the theorems. So I'm going to jump ahead, as I mentioned, over here to this other one, and then we'll do some sample problems. This one's with a tangent here, so we're talking about secant. This one is, we'll call this A, we'll call this B, and we'll call ED, we'll call that C. This one is A times A equals B times C. And again, C is this entire length right here, not just the little part from C to D, not just that chord there. So that's what those are the main takeaways from these theorems. Okay, let's just jump into some practice problems here. They're all pretty quick once you know the theorems. All right, so here's the first one. What is the value of x? We're going to do 4 times, and again, now we have to use this whole value there, that's 9. So 4 times 9 equals 3 times, this whole length here is 3 plus x. So we have 36 equals 9 plus 3x. Subtract 9 to get 27. Divide by 3 to get x equals 9. So the math behind this stuff really isn't too difficult. So here we have 6 times 15 equals 5 times 5 plus x. And then you can solve that. Here I have x times 3 equals 4 times 6. Solve that. Here I have 3 times x plus 5 equals x plus 1 times, but this is going to be interesting, this whole length here is 2x plus 1 minus 1, that's 0, so it's just 2x. This one I'm actually going to solve because it looks like we might have a quadratic here. 3x plus 15 equals 2x squared plus 2x. If I distribute this 2x there. Okay, we're going to bring everything to the same side. So I have 2x squared, I'll subtract the 3x. That leaves me with negative x. I'll subtract the 15. Minus 15. Okay, so this is a quadratic where a doesn't equal 1, a equals 2. So I'm going to try to factor this using the box here. We'll see if I can get it quickly or not. I need two numbers that are going to multiply to negative 15. And the two numbers in the other two boxes have to add up to negative 1. So I would try 3 and 5. This will be 5x. If I put a 3 here, this will be 6x. So 3 times 2x is 6x. And then it needs to be negative. So this negative 3 here makes that negative. Okay, so there we go, 2x plus 5, and that works all nice. You could use the quadratic formula to solve that too, I guess, but I like factoring if I can. So my two solutions are x equals 3, that's that one there, and then x equals negative 2.5, that's that root there. I'm going to go back up since I have a negative number. A lot of times the negative numbers won't work, and so if I plug in the negative 2.5 in for x into here, or here, or here, gives me a negative value for a side length, and I don't want that, so we're gonna cancel that out and just be left with x equals 3 for our answer there. Good problem though, I like that one. Okay, and then a couple more problems here. Here we would have x times x squared equals 1 times 4. The whole length of this is 4. So x squared equals 4, square root both sides, x equals plus or minus 2, but we don't want the negative 2 because the negative 2 would not make that a side length, so we'd get rid of that negative value there. So you're just throwing out answers that don't actually make sense. Here we'd have 7 squared equals 5 times 5 plus x. We could solve that equation. And the last one we'd have 12 squared equals x times x plus 10. And this one's going to be a quadratic, so I think I'll solve this one for you guys. So 144 equals x squared plus 10x. Subtract the 144 from both sides. And I need two numbers that are going to multiply to negative 144 but add to 10. Numbers we're looking for are 18 and 8, x plus 18, x minus 8. Those two numbers are going to multiply to negative 144 but add to 10. So x equals negative 18 and x equals 8. I'm going to check my solutions. Negative 18 would make this value negative, so I don't want that. So I'm going to throw out negative 18 and be left with 8. Okay, and then I got one word problem here. You want to find the length? Here's just a bunch of information. They have everything. Let's see, each. All right, we have 3 moons. Each has a nearly circular orbit. 285,000 kilometers in radius. Okay, let's see. Find the distance from D to B. Okay, so that's all I want. D to B. Okay, well, let's call this segment X here, and they give us enough information just in that picture there. So I have read all those words, and they're basically useless. 203,000 squared equals 83,000 times 83,000 plus x. And then, so just using the theorem we just worked with, you could solve that for x and get your answer. So I don't know why we have all that information there when they give us that wonderful picture with everything we need. And there's your assignment. Thank you guys for tuning in, and I'll see you for 10.7.